Hello everyone, welcome to Hydropower. Today in this lecture we'll talk about the Pelton turbine and its design procedure. So let's start it. The Pelton turbine. Pelton turbine is tangential flow impulse turbine, consists of a circular disc on periphery of which two low buckets are mounted where the water strikes the bucket along the tangent of the runners. The key features of Pelton turbines are energy available at the inlet of turbine is kinetic energy. This turbine is basically used in high heat projects. The pressure at the inlet and outlet of turbine is atmospheric. Now let's talk about the main parts of the turbine. The main parts of the turbine are casing, which is called as the spiral casing also, and the nozzle. The second important part is nozzle. The third one is runners with buckets, and the fourth one is braking jet. So let's know a little more about the main parts of the turbine. The nozzle. The nozzle directs the flow in the buckets. There are up to 6 nozzles, all arranged symmetrically and causing the rotation in the same sense, but practically maximum number of nozzles in a turbine are only 2. And third one is runner with buckets. The runner with buckets consists of a circular disc on the periphery of which a number of buckets evenly spaced are fixed. The space of the buckets is of a double hemispherical calf where each bucket is divided into 2 symmetrical parts by a dividing wall, which is known as a splitter. And the next point is casing or spiral casing is the outer covering of the runner that protects the runner, and its function is to prevent the splashing of water and discharge water to tail race. And the last one is braking jet. The braking jet is an additional nozzle that directs a small stream of water onto the back of the Pelton wheel after it has been stopped by the main high velocity jets. After all these, now let's go to the design of Pelton turbine. Before going to the design step or procedure, let's clarify the design parameters that needs in the Pelton turbine. The design parameter are specific speed and as design speed, and the diameter of runner wheel is D, diameter of nozzle is D, and the width of the bucket W. After this, let's go to the major design procedure. First, we will find out the velocity of jet at inlet is given by V1 is equal to CV root over 2GH, where H is called as the net head and the CV is coefficient of velocity that varies from 0.98 to 0.99. And in the second step, the velocity of jet in the turbine is determined by V bar equals phi root over 2GH, where phi is called as the speed ratio or speed factor. It is varies from 0.43 to 0.48, where V bar also called as the tangential velocity of the wheel. And in the third step, the angle of deflection of the jet through bucket is considered as 165. While doing the numerical problem, if this value is not given, then we have to consider the 165 degree. If this value is given, then we have to take the given value in the question. And in the fourth number, the mean diameter of the Pelton wheel is given by V bar is equal to pi dn by 60. This can be transformed as D equals 60 V bar by pi n, where the mean diameter is also called as the pitch diameter. In the next step, the jet ratio is calculated, where the jet ratio is denoted by M is equals capital D by N. D, where the jet ratio is the ratio of pitch diameter to that of the diameter of the jet. The jet ratio varies from 10 to 15 numbers, but for the most economical it is used as 12. After that, the number of bucket NB is calculated, where NB is calculated by using 15 plus capital D by 2D. And after calculating the number of bucket, we'll calculate the bucket spacing. That's S equals pi D is divided by NB. After all this, we will find out the working proportion of the Pelton turbine. In the working proportion,
width of the bucket is varies from B equals 3D to 4D, and in a similar way the radial length L is varies from 2D to 3D.
Is equals 2D minus
the depth varies from the
diameter of nozzle
0.8D to 1.2D, where in the above working proportion the D represents the diameter of the nozzle.
So in this Pelton turbine definition, main features, main parts and design procedure, we end up the lecture for this much. In the next video, we'll come again with the different numerical problems related to Pelton turbine. Till then, keep on watching our videos and don't forget to subscribe us. Thank you.